If white sugar was produced like this, would you still want to eat it? Every sugarcane season, workers use this vehicle to harvest the ripe sugarcane. Once harvested, the sugarcane is placed into containers next to the field. A truck quickly transports them to the sugar mill for processing. Upon arrival at the mill, the truck unloads the sugarcane into containers, which are then fed onto a conveyor belt that's in operation, preparing for a double wash. After the washing process, the sugarcane is fed into a cutting machine that slices it into small pieces like this. These pieces are then returned to the conveyor belt, moving them towards a machine for extracting juice. To remove as much water as possible, the sugarcane is pressed multiple times. Workers oversee the machine's operation to ensure that no trace of sugarcane juice is left in the pulp. The extracted juice flows through a final pipe into a large container before being crystallized into sugar. Samples of the sugar are rigorously tested in the laboratory, where engineers add thickening agents and deal with impurities. This results in a clean liquid that is poured into another machine to assess whether the sugar content meets the standards. Next, the juice flows down from this 10-meter tower. CO2 gas starts rising from below, initiating the drying process. Its purpose is to decolorize the next batch of sugarcane juice. The juice passes through a separate device to check its pH. Lime powder is added to the water, helping it thicken. After this thickening process, the juice and lime will mix and settle for about 6 hours. The pH and clarity are carefully regulated during this time as a reaction occurs, transforming the juice's color from dark to a brownish-yellow hue. The sugarcane juice then flows through a pipe into a cleaning area, where it waits for around 2 hours to complete the cleaning process. Simultaneously, impurities settle to the bottom, and workers take samples to understand how these sediments will behave and whether they can be used without wasting them. A second pressing and filtration occur to extract any remaining sugar from the sediments. After pressing, the remaining mud-like residue is returned to the sugarcane fields as fertilizer, while the sugarcane waste will serve as fuel. The cleaned sugarcane juice, now containing 15 to 60% sugar, is fed into this 15-ton machine. Any remaining sediments float to the top. A rotating scraper on the surface pushes them out. The previously liquid sugarcane now transforms into a dense, sticky form. Next, workers add a white adhesive substance to the sugarcane water. This milky substance combines with the sugar, making it easier to refine into white sugar. Subsequently, the mixture is placed in a large boiling pot to crystallize into sugar. As water gradually evaporates, workers regularly check the progress of crystallization until it reaches the desired consistency. The resulting crystallized sugar mass is transferred to a high-speed centrifuge. It spins at 120 revolutions per minute, rapidly separating the sugar from the pot. Only the pure crystallized sugar remains in the pot at this point. The centrifuge sprays clean water to wash the crystals, removing impurities. Once the process is complete, the water is drained, leaving behind clean, crystallized sugar. This centrifuge operates on a similar principle to a washing machine, extracting water from the sugar just like a washing machine extracts water from clothes. The crystallized sugar is then removed from the centrifuge and gradually fed into this large drying machine. It keeps rotating until the sugar's moisture content drops to 0.2%. After drying, the sugar is placed into bags on the ground. Once the bags reach 1 ton in weight, machinery helps move them to another section of the factory. Each bag is carefully opened, allowing the sugar to flow into a packaging area. Automated equipment handles the packaging process, moving the bags along the distribution line. From there, this white sugar can provide for thousands of households.